All right, it's great to see a bunch of you out here interested in this topic. Let's start with having just a slightly casual conversation, and then we'll look at some slides, and we will write a lot of code, which is what we should all be doing to understand how code works. All right, so for those of you who just walked in, you'll be able to get this stuff on GitHub. I'll show you the URL later. We were having an interesting conversation, some of you guys who were early in me, about sort of, is .NET popular in Silicon Valley? Where is it popular? Where is it not? And so I thought it might be worth pulling up this picture, which we talked about here. So I wrote this article. It's a blog post, really. It said, ever wonder how big, relatively speaking, .NET and Python are to each other? Right? I mean, I, like you guys, have spent much of my time doing .NET development. I published or sold my first commercial .NET application before .NET was released. Long story there. Anyway, so for a long time, right? And so I love .NET, but Python is also really amazing, as we'll see. So I was always wondering, well, what's the sort of relative interest in these two technologies? So I did this post. I went to this place called Meetup, meetup.com. I don't think it's a thing here, but in the US, this is a big thing. There's like thousands of meetups per city. So I could come over here and I say I'm interested in London. Let's say I'm interested in Python here in London. And these are all the Python user groups within 5 miles of this location. Okay? And you can do that for .NET, and you can do that in different cities. So what I did is I went and I made a graph of this stuff. And I did that for .NET, and I did that for Python in a bunch of cities around the US. Chicago, Los Angeles, New York, Silicon Valley, for example. Look at the orange. The orange is close to equal in a lot of places and overwhelmingly huge, relatively speaking, on others. Okay? And these are not specialized user groups like data science for whoever, right? These are just the plain, straight up .NET, Python user groups. So for example, in Silicon Valley, Python is 28 times more popular than .NET, which is kind of a sad statement, but it is what it is. So let's come back, maybe I'll pull this up later. There's a really interesting sort of case study of like insanely large projects written in Python. But let's start at the beginning, which this is the one. Actually, so let me open it like this. Okay, so, geez, sorry. You guys want to learn about Swift? There we go. All right, so my name is Michael Kennedy. I work for a place called Developmentor. I've been doing Python for years. I've been doing .NET for as long as there has been a .NET, and so on. And just love programming and want to kind of share some similarities and differences between these two languages with you guys. All right. The basic theme of this presentation is you guys are all .NET developers. This is my assumption, and that you love .NET. There are many things about .NET that make it special. Like, what are some of the most amazing things? You guys yell them out. What thing are you doing in C# or .NET? They're like, I could not leave this language because I would not have X. I'll get started. Link. Who would not leave because you would have to go do something other than link. You'd have to go back to like select star from. Like, no. Right? What else? Yield return. You guys use yield return ever? That's amazing. Entity framework. Entity framework is really cool, right? Not just because of the link stuff, but just on its own, right? I have an object, I make some changes, I call save, boom, it's magic. For each loops, list, all these different things. And I have a whole list we'll go through. But the idea is almost everything that, at least when I sat down to think of it, and probably you guys as well, when I sit down and think, what is super awesome about .NET and what would I really miss if I had to go to Java or C++ or something like that, you'll find an exact equivalent or very, very comparable thing in Python. But Python runs in many more places than .NET. I know the .NET guys with their server core are kind of sort of trying to fix that, but it's still just server core, right? It's not full-on applications, all right? So we can take whatever we do here today, except for one small part, and we could run it on OS 10, we could run it on Windows 10, or we could run it on Ubuntu, and we would make no changes to it. And that's pretty powerful, right? That's something that we wished we could have with .NET, but we don't get. All right. So quickly, what is Python? It's a high-level language, very much like C#, only slightly higher level, because you just say less and it figures out more. Many people consider Python to be an interpreted language. And if you just go type Python, run this, run that, it is an interpreted language. But there are many different runtimes. Like we have the CLR and Mono. There's like 6 runtimes for Python. Some of those are JIT compiled to machine code. Some of those are interpreted. But the plain vanilla out of the box one is interpreted. It's very object-oriented. Everything has a base class. You can override methods. Like it's very C#-y in that sense. It's a strongly typed language in that the things you create have types. I can go to an object and say, what is your type? And it'll say, I'm a customer class. OK, cool. But it has dynamic semantics, which means basically the types don't really appear in the languages. Okay? But the pointers that point out things, the things they point out are strongly typed. The language strongly emphasizes readability. Right? It sort of makes the correct, in my opinion, assumption that code will be read many more times than it will be written. So let's make the syntax about making it readable. Okay? And you'll see they take that to kind of an extreme, which will probably shock some of you if you haven't seen it yet. Just like we have assemblies, sort of DLLs, NuGet, all that kind of stuff, same type of thing here. You can basically add a reference to a thing, and so on. You'll hear the term when people describe either Python itself or libraries that people use, like Entity Framework equivalents, to say that it comes with batteries included. That's a popular saying that you'll hear all over the place. And that just means you don't really have to go write a bunch yourself. You can just kind of grab this library and that library and use it, right? Very similar to .NET in that sense. Dissimilar to, like, say, C++. So the most shocking, different, funky thing about Python is how they define sort of the shapes and blocks of code compared to many other languages. In Python, the way that you define blocks of code is not with curly braces, it's with white space. Okay? White space. So if I want to make a method here, I would say define some method, colon, and then I would indent 4 spaces. Everything that's indented 4 spaces is a part of that method. When I stop indenting 4 spaces, it's no longer part of that method. That will freak you out if you didn't know that. But before you flee the room, the tooling, the equivalent of Visual Studio, and in fact Visual Studio itself, deeply supports this. Right? So if I type def colon and hit enter, it automatically will go here. If I type if colon enter, it'll automatically go here. If I would type return, it would automatically jump back here. Right? It basically is not a thing that you have to like juggle yourself, but that's how it works. So thank you, that looks better. You also have no semicolons. Parentheses are not so required, right? So here's our if statement. We have no parentheses here because, you know what, they're not really needed. Why do we have to type this stuff? It makes us feel like cool programmers, the more symbols that we can put on the screen, but is it really needed? No, right? Languages that are just coming out, like Swift, also have no parentheses around their if statements and while loops and so on, right? Because they borrowed it from Python, really. So this part takes a while to get over because it's just different. And I remember thinking, oh my gosh, am I really doing this, you know, as I was working with it. And then I went back to C# after a week of writing Python. I'm like, wait a minute, curly, parentheses, I'm like, actually, okay, this is not so bad. You'll find it's really quite nice, and it just is very different. So everything else is quite comfortable. This is funky. All right, so let's just do a quick little demo. And we'll start by doing the demo in my Mac, but later we'll do some demos over on Windows 10. Okay? But let's just start over here. Now, most of the time when you see people doing Python, they'll do something like this. They're like, okay, Python is awesome. Let me show you how awesome Python is. And you'll be like, no, this is not awesome, right? Because that is not the way that we like to work, right? You're like, are you serious that that's awesome? That is not. And so then they'll say, no, it's really awesome. Let me show you this. And they'll open up Sublime Text, which seems to be hiding somewhere. Oh, well. We'll open up something like some basic editor and start working, right? But the world is a better place than that. They just are kind of doing their own thing. So we'll open up this thing called PyCharm, which, how many of you guys wished that the people who made ReSharper actually made their own standalone Visual Studio that was like totally, had nothing in it but what ReSharper does? It's so awesome, right? That's what this is. This is from JetBrains, and it's like just a Python editor, which is cool. This one runs on Windows, OS X, and Mac. Has a free version, kind of like the community version of Visual Studio and so on. So we'll just do a quick little demo here. And just so you can see, like when you get started, similar to .NET, it says what version of the runtime do you want to pick. You know, when you say file new project, you say .NET 4.5.1, 4, 3. Please don't say 3. Okay. We're going to work with Python 3, and we're going to put this somewhere. Let's call this, just call it, that's very creative, isn't it? It's too early to do more. Okay. All right, so I think the fonts might just be a shade small in this. We'll find out. So here we are in this PyCharm thing, and at some point it will freeze up for about 5 seconds as it tries to understand the IntelliSense. It's unpredictable when that will happen. So if it stops working for a minute, that'll be why. So what we're going to do is we're going to add a new file, and we're just going to call it program.py. Okay, and let me just type some fonts over here. Sorry about this. Did not expect the screen to be so large. All right, so here we are in our program. Now what I want to do is just give you like a super quick, how would this look in C#, how would this look in Python example. So what we're going to build is like a super cheesy weather application. It's going to go through all the days of the week, and it's going to say, on this day, the weather is going to be, you know, sunny, rainy, foggy, cold, whatever. So let's see, how do we get started? In .NET, we have a main. Here we can have a main. And remember, the way you basically define a block of code is you say colon. Hit enter. Is that font big enough for you guys in the back? You want it larger? It's good? Okay. You must have good eyes. Okay, so, and notice when I hit enter, it goes like that, right? Right where it needs to be for this indentation funkiness. And if I hit backspace and tab, it looks like, oh, there's the freezing up part, I told you. So in a moment, it'll go in like 8 spaces. So it looks like there's tabs in this thing, but if you actually arrow key, there's spaces. So the editor is all about like helping you manage this indentation thing. All right, so what we're going to do is we're going to call a couple of functions. Now, first of all, notice this has no return type specified, right? It doesn't say void, it doesn't say int, because every function returns something. Even if you say it returns nothing, it just returns the equivalent of null, which is none in this language. So you don't have to say it returns something. And there's no types in the language syntax, so you don't have to describe what type it is. So why would you have to just say, you know, returns a thing? It would basically be like writing object here. All right, so it's, you don't say anything, and then you would have parameters here like thing A, thing B, but you wouldn't have a type with them, okay? But this is a void method, basically. So what we're going to do is we're going to call 2 functions. First, we're going to get a thing that returns a list of days of weeks. And if this was in C#, I would write this. I would write list of string days equals, let's say, get days of a week. All right? And up at the top, I would write something like this. Public static list of string, curly, curly, right? What I'm going to write instead is I'm going to say def get days of week. All right? Just, I don't need all this stuff here, right? It's just less. All right, so then I want to create a list. And in C# I would write, I mean, I know you could use var. Let's do it that way. So, okay, this will be the best C# thing we could write. Days equals new list of string of, all right, put stuff in there. We also have this concept of a list in Python. Literally, it's a growing thing. It's basically enumerable. You can add and subtract, you know, items from it and so on. So the way we would say that, the way we would say that in Python is we would say this. Right, same statement. Okay, but we want to fill it up, so we'll put the days in there like so. And you would put that in the curly braces where the dots are. Tuesday, Wednesday. This part's fun. Friday, Saturday, and Sunday. And then we want to return those from our thing. And by the way, in C# that would be the same, but it would look like this. And if you really feel like you're missing a semicolon, you can actually put semicolons in here. They just don't do anything. Yeah. Somebody did a
Like you define like first day, Monday is 0 and has 1 internally, but still represented as Monday, Tuesday, Wednesday, 0.
Yes, you would basically create an enumeration or something like that. Just like you would an enum in .NET, I think is as close as you're going to get. Yeah, or a dictionary where it has a lookup, one of the two. So down here we'll say days equals get days of the week, like that. And then we want to basically, for each day, go through it, and we want to get some random weather reports. So let's first write the get the random weather report. So this is going to be awesome. We'll say get weather, and we're going to take a day as a parameter here. Now remember, C#, this would be public static string get weather of string day, parentheses, right? That's what we would write. And down here, I'd like to use there's a very professional technique. These guys that study the weather, they go to, meteorological school. Some of them have PhDs, all sorts of stuff. So I'm going to use a technique that they use a lot to predict the weather. And I need another library in order to do that. Right? So in .NET, I would type using something, but I would also go add a reference to it. In Python, that's all kind of in one thing with this import keyword. So I'm going to say import random here, and I'll say index equals random dot randint. This is how you might do this in C#, right? You would say, give me a random integer, and maybe you would also have some reports. So we'll say reports. I'm going to stop writing the C# stuff. You guys got it by now. Sunny, hot, cold. I was in California, it was smoky, foggy, and so on, right? So in .NET, I would write this, and I would say return reports of length. This is how you say it. It's kind of annoying that it's not on the object, but length of reports minus, no, I would say, sorry, over here, I would mod this by length of reports, yeah? Then I would return index. And you'll see code like this a lot when people come to Python because they're like, this is how I know, this is my way my brain works. But there's often a time that's a way in Python that's more clear, more focused than this. And when you see code like this, they call it sort of non-Pythonic. They say, this is not the way I would do it if I were really a Python developer. This is like the C guy who copied his code and like took away the semicolons until it would run, basically. So there's actually a better way than doing this. I can say this instead. Return random.choice of reports. Right. Here's a set. I want one of them randomly. Give it to me. Right, so you'll find this kind of stuff is common in Python where it's like, well, you could do the algorithm, or you could just say, do this, and do it, right? So this is really nice. Let's apply this little technique down here. Let me make some space. Dun, 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 dun. Okay, so in .NET, if I had a list, if I had these days, how would you go through it? How would you iterate over them to work with each of them? For each, right? Obviously. So we don't have for each in Python, I'm sorry. We have for D in days. They have for each, they just don't have the word, right? It's just, they're literally, what is kind of amazing is there is no indexed-based for loop. This is the only kind of for loop. You can say things like this. You can say for I in range from 0 to 100, but you can't, there's not a for I equals 0, I plus, there's this way. So that's pretty cool. So let's go down here. I'm going to say report equals get weather of the day. And then let's print it out. In .NET, we'd say console write line. Here we just say print. Oh, and you know one thing that's really fantastic that I just would miss from C# is this. I would love to be able to write this. The weather on curly 0 is curly 1 dot. Right? That format, like, I'm so over %s, %d, %f, .2, like all that, you know, C style formatting. So it's cool that we can do that here too. Right? And in fact, there's a whole lot more features around this one. I can leave these out if I have them in the same order. I don't have to name them. If I had a dictionary, this could be weather, and this could be day. And if there was a key for a thing for a day and a thing for weather, it would actually pull it out of the dictionary. There's all sorts of awesomeness here, but we'll just stick with this one. All right, now, if I run it, you guys might expect something awesome to happen. It's not. If you look up here, there's no little, it looks like there's a run thing. If I hover over it, it'll say run, but it's grayed out. And that's because I haven't sort of told it what to run. So you right click, and you say run program, and it's hard to see down here, but nothing happened. And it's because we have not called this function here. Right? So we just need to call this at the bottom. And there's no like auto invocation of your main. Like this main, I made it up because I'm a C style person. Right? So now if I run it, you can see the weather is foggy, and it's sunny and sunny and so on. What do you guys think? Nice? Not nice? Interesting? You're not really there yet, I know, because you've had 10 minutes of it or something. We can run it again, get different weather. Smoky. All right, but just look at the gray parts were what we'd have to write for C#. And look at the parts we actually did write. You're going to see this as a theme throughout this presentation. Okay? And brevity is not always perfect, but a lot of times it turns out to be really nice. So let's go look at a little bit of the slides here. Go back to this, all the way back. Okay, so remember I told you there was a list, this is my list, of what is awesome in .NET. And if I had to go to another language, I woke up tomorrow and my company said, Michael, you're a Java developer. First I'd go in the closet and cry for a while, and then I would come out and I would say, I'm going to miss these things, right? Why were you crying? Well, because I had reference, I can't, you know. All right, so just look at some of these things. We've got system.object, you've got this common base type. Like, I don't know if you've ever done C++. There's like 6 types of strings, and there's no relationship between them. It's horrible, right? So it's easy to just sort of appreciate this by not noticing it, which is great. For each loops, amazing. Classes with properties, like computed properties rather than getters and setters. Anonymous types, ability to do like add reference. NuGet, like NuGet is so super amazing. You guys know NuGet? Yeah, getting there? Okay, awesome. Entity framework, debugging, like, you know, some of the people you'll see doing, I don't know, Objective-C type stuff or other languages, they'll say, okay, so now you just open up the terminal and you type this command to open it in the command line debugger. You're like, what did you just say? No, command line debugger? Are you serious this century? So great debugging tools, ASP.NET MVC, Link, Visual Studio, the ability to have like stuff running side by side with different versions, iterator methods, anonymous types, lambdas, JIT compilation, resharper, all these things, GUIs. All of these things are things that I think not, you know, GUIs are not, GUI designers are not unique to .NET, but you know, Visual Studio is kind of special among a lot of the design tools for building like really quick and easy UIs. Yeah, if you've tried Xcode, you know there's an alternative to that that is not so easy. So these things are great. And what we'll see is every single one of them exists in Python, sometimes in a much better way. Right? So you might think, there's no way I could do without Visual Studio. And I showed you already, I showed you PyCharm, and PyCharm is awesome. But let's come over here. Say, there's just no way I could live without Visual Studio, so I can't go do this Python thing, I'm sorry. So I'm going to come over here, I'm going to say File New Project, and go to Python. Say I would like a Python application. What kind of Python application do you want? Now, you might think, oh yeah, Michael, I've heard of IronPython, and I've heard that it's pretty awesome, but nobody uses it. You can see down here there is an IronPython thing. All of this stuff, this is the kind of Python that runs on Linux, or runs on Mac, or on Windows. right? So the thing that we just made, let me just go over here and create a Python application. And we'll just throw it there, it doesn't really matter. Mess up my desktop, I guess. Let me go over to this guy. And it's almost there. It's a lot of work to create a text file. Okay, so there's this thing called Python tools for Visual Studio. And I can come over here, paste this, hit Control F5. Look at that. That's awesome, right? Now you're like, oh yeah, okay, that's probably IronPython. Nope. If I go over here, I don't even know what that was. Add remove Python environments. You can see this is Python 3.4 or 2.7. Python, IronPython is an option, but that's not what this is, right? And in fact, if I go over here and I type get, I have same IntelliSense here. I can go put a breakpoint here. I can F5 it. Whoops, let's put it down here. Hit F5, breakpoint, hover over. What does reports look like? Right, that's regular Python. You also can do IronPython, but regular Python. So that's pretty sweet, right? That costs all of nothing, which is cool. And then I'm also using, if you guys are not aware of it, Visual Studio Community Edition, which is basically the rename, given away version of Python, or sorry, Visual Studio Professional. So that's awesome. So you can basically get Professional Visual Studio for free now, and then all the other tools as well. So this is great. We'll maybe come back and look at that when we get to the UI stuff as well. We might build like a WPF thing there. Okay, so Visual Studio, can't live without it. Okay, cool, don't. Just use these tools, it's really nice. But of course, really what I would use if I were you is PyCharm. You guys saw the options in my little menu there, right? For Visual Studio. If I go over to PyCharm and I hit options, this is about the editor. But here's the project. And you have basically all these management tools for managing basically what is the NuGet stuff and references. You've got stuff built in there for certain types of debugging that's not available in Visual Studio. There's just a lot of stuff that's kind of better over here. But Visual Studio is great as well. All right. So PyCharm, very nice. Check it out. Again, debugging, I already showed you. If you want to set a breakpoint over here, just set a breakpoint over there. It also, not surprisingly, works in the PyCharm one. Right? Very, very similar. I think the debugging experience is slightly better in Visual Studio because you get those little hover, pin, expando, visualizer things. But about the same. All right, so C#, everything is an object. That's really cool. In Python, everything, Python 3 at least, everything is also an object. Right? Same thing. Literally, they're both called object. Right? So you have this sort of common base class. Turns out it matters less in Python than it does over here, but you'll see there's a bunch of what are called magic methods. Python is a little underscore happy. So if you kind of want to override an operator or something, you would say underscore something underscore. So here to override toString, we say def string. Right? It's not too bad because you type def and then boom, here's a big list in PyCharm or Visual Studio of what you can do. But just get a sense for like how much you have to type on each of these, right? And how much you have to read, right? This just not as much kind of fits in a comfortable space on the screen, right? It's not like I got my fonts down to 0.8 so I can see a lot, right? It's like there's less to see. Okay, for each loops, you guys already saw this one, so it's a bit of a giveaway, but that's pretty fantastic. I can create these numbers and I can loop over them. You can also do that here. Less writing, less fuss, but you can still do it. And it basically means the same thing. If you have a custom class, you can do certain things to it. All right? So in C#, you can say, no, C# is awesome because we have IEnumerable of t. And that means we can implement IEnumerable of t. Here's some type, and here was some of the actual implementation of our class. We can implement public IEnumerable tuple of string of float of that and get a numerator, and we can do this, or we also have to have this like downgraded non-generic version here. Like, that's awesome. Yeah, so it's pretty awesome in Python too. So let's go check that out. So let's go over here, and I'll just add another file here. We'll call this shopping. And let me just tell it to run, so we run the correct one. So we'll open here, def main. If you want to leave it empty in C#, you would have curly braces, right? Just say, I'm not going to write this part yet. I'll get back to it. Just hold on. There's no curly braces here, so you need some way to say, like, this part is empty. So we have this keyword pass, okay? So I come up here and say, I want to have a class. And a class definitions are very simple. So I'm going to have, let's say, a shopping cart. Let's just call it a cart. Okay. And in here, I'm going to have some member variables. Now, one thing that is freaky to us being C derivative language folks is the white space. The other one is how you define member variables of a class. So in .NET, I would come up here and I would say, you know, public list of, what did I have? I had tuple, but we'll just say item. Let's do it like that. Items, get, set, something like that. And you would just say it there and sort of declare it as part of the structure. And you technically can do this with Python as well, but those are more or less static if you were to. So if I said this, if I said items equals a list up here, that's basically a static thing on my class. It's a little bit more complicated than that, but let's not worry about it. The standard way to do this is you basically say that you want to use them in the constructor. And the constructor is this thing called the initializer, not the constructor, and it's a magic method, so it has a double underscore. So you'd say init, and there's this self keyword. This is like the this that you're familiar with, except for it's not implicit. That's actually a little bit annoying. So you have to have this self parameter. Like you saw, I didn't type any of that. What I typed is underscore underscore enter, but it is something that's in the code. So what I would do is I would say I would like this to have a thing called items, like that. And this dynamic assignment of it is how you basically declare the variables. But all the tooling and stuff knows about it. So if I say C equals cart, C dot, it knows there's the items, okay? So that's like how stuff works. So we've got our items over here. And right now this makes them public. We can talk about making them private if you guys care. So I want to basically implement IEnumerable here. Let's get rid of this stuff because it's irrelevant. All right. And let's say we're going to have a cart item. Class cart item. And it's going to have some variables. And we're going to have, let's say, a name. And we're going to have a price. Because this is basically a resharper thing, I can, no, I'd have to do it the other way around. A lot of times it'll automatically like add them up here, like resharper word, right? So like this, because I'm not doing anything with them, is it? Price, like this. Okay, so down here this can be an array of cart items. So let's say def add, and it's going to take an item. Also notice over here I typed def add parenthesis, and it automatically typed all that. It's like you have to do the self thing as the first parameter. You never have to type it, but it has to be there. So we'll say item, and then we'll just go down here and say self dot items dot. We don't say add in Python. We say append. Right, but that's a pretty small mental transition there. So what we need to do is we need to implement IEnumerable, and we don't have static types, so we don't declare like an interface we're going to derive from. We're just going to override one of these magic methods, which will be iter. And that is like what the for each loop looks for, just like it looks for get enumerator in C#. So I can just say this. I could start by saying return self.items.iter, right? So in .NET, if I had a list and somebody said, get me your enumerator, I could say, well, just use the list ones and return the list.getEnumerator. So this is the same thing. It just has lots of underscores in it, okay? There's other ways, so like let's use this really quick to show you that it works, and then we'll do something else. So down here in our main method, let's create a cart. You don't say the new keyword, you just say cart, but if it took variables or arguments, we would put them there. Then we can add some items, say cart dot add, and what are we going to add? We're going to add a new item, so it'll be a cart item, and in here you can see it takes a name, so this will be like what do we need? We need bread, and it's going to be $2.99. And while we're out shopping for bread, we might need milk, and that's going to be $4.99. And around the corner is the Tesla store for awesome electric cars. It's only 120,000, so we're going to throw that in there. And we might want to ask, what is the total? Right? So we could say total equals 0 for item in cart, total plus equals I dot, and we'd say price. And we'd print something like this. The total is, you guys want this in pounds? We'll put it like this. We can say, there's some format I can put here to put 2 decimal places, but I forget what it is, so I'm just going to say separate with commas today, something like this. And we'll say dot format, total. Now again, if I run it, nothing will happen because I'm not calling main, so let's do that at the bottom. No problem. Hope they take cash. Anyway, is that cool? Right. So let's go back and look at how this, just compare it one more time against C#. There it is. Which of those would you rather write? Which of those would you rather read? Exactly. Every single slide is like this, pretty much, except for maybe one. Okay, properties in C# are awesome. I mean, they really are. This is like, I'm so over the get and the set method from C++ and Java. These are not good ideas. All right, so the ability to write this computed property is really fantastic. We can go over and say public float, total price, get, da-da-da, and then there it goes, right? This is assuming that it's the same cart with other values. We can write this in Python as well. It looks like this, right? You just define a method, and then you put this, like what it's called a decorator. It's basically, think of it as an attribute on there. And it turns it into the use case. If you look at the bottom down here, exactly the same use case. Okay. The writing side of it looks a little funky, but once you get used to it, it's no big deal, right? But it's definitely less ceremony. So that's kind of cool. All right, so you can have in .NET these things called anonymous objects. And that's pretty fantastic, right? I can come over here, and if I just want to hold an ID, which is an integer, and a register value, which is true, I can come and just new up this thing, and locally I can use that, right? So I could write it out, and it would look like this. And I could say if, right, work with its values, and so on. In Python, they don't technically have one of these things. However, we can do a little bit of work and create one ourselves. So what we can do is we can say, I want to create a class that derives from the dictionary class. And I would like to replace its get attribute and set attribute, which are its set value and read value, sort of method operators, if you will, with just go to the dictionary and get the item and put it back into the dictionary. And then we have anonymous objects, just like we have in .NET. Now, this is not quite as perfect. So a lot of times it's like, yeah, this is really cool. See how much nicer this is. But this one you get IntelliSense. That one you don't really get IntelliSense. So I'm not going to tell you that these are the same things exactly. But if you're doing kind of like projections and stuff out of queries, it's really nice to have that kind of stuff. Okay, and by the way, if you guys have questions, please stop me. Lambda expressions. Now this is really cool. I can have this private static, oh, not this again. I have this private static thing that returns an enumerable of int, and it takes a predicate. What we can do with this predicate is it's going to go through a bunch of numbers here. And as it's going through the numbers, it's up to this method that we pass to determine are those numbers in the set or not in the set. So I could come down here and I could say, I want to generate a little lambda expression here that given one of the numbers in here, only include it in my set if it's divisible by 11. So I can basically say get all the multiples of 11. So 0, 11, 22, 33, and so on. Right? That's pretty cool. Let's see if this is possible in Python. Okay. All right, so we're going to go down here, and we're going to have that predicate method, or the method, what did I call it in my thing? Find numbers. Okay, so we're going to say def find numbers. Instead of using camel casing like .NET does, they use snake casing, which obviously, like, I think that's obvious. You have to use snake casing if your language is called Python, even if you don't like it. So this is how you separate things. So what I'd like to do is pass in a test, or I guess I call it predicate, so let's use that here as well. And suppose we had these numbers. We said we had our for loops. We said, how did we do it? I think we had numbers was equal to this. We said for n, and we'll do this range thing. So we'll say 0 to 100. That's more than 100. And we'll do the predicate. We'll say if predicate of n, if that's true, we want to say append that to our list, right? And at the very end, say return nums. See if that's what we wrote. More or less. We use the yield return keyword. We'll talk more about that in a minute. So this looks like a similar thing. And it would be nice if we could take this function. I mean, I don't know about you guys, but when I first saw Lambda, I was like, oh my gosh, this is just so amazing, right? First I was like, what is that doing? How is that even going to compile? And then after I understood, I'm like, okay, now that's awesome, right? So we can come over here, and I could run some code. I could say print, and we'll just print out the string representation, whatever comes out. Find numbers. It would be so awesome if I could say this. Lambda n goes to n mod 11 equal 0. Like, wouldn't that be cool if I could say that? Cool, huh? So it's quite similar. You'll see sometimes there's these little squigglies right here. And that's because there's a more formal layout. There's a specification for the formal layout of how you're supposed to do your code, right? Basically a coding standard. And that's called PEP 8. It's probably hard to see, but it says PEP 8 white space after this thing. And PEP 8 is the proposal. It's called a Python enhancement proposal. And that's what it was originally. It got adopted, right? And so there's all these rules about how stuff's supposed to be laid out. So those are rarely errors, if you see those squigglies. If it still runs, they're probably not errors. It's just this. And so in PyCharm, you can hit a button, and it just fixes all of them. Kind of like reformat code in ReSharper, okay? So this is pretty cool. Right. Again, which would you rather read and write all day long? Don't get me wrong, I love .NET. I'm not bagging on it. But this is a theme that occurs over and over, and it's fun to write Python too. And it gives you a really nice cross-platform, high-performance language. All right, LINQ. Now, LINQ is one of the crowning jewels of .NET. It has to be. It is a piece of pure magic. Now, Python doesn't exactly have LINQ, but it has something very similar to LINQ. But one of the things that's beautiful about LINQ is this could be an in-memory array. This could be a SQL database that's sort of linked into by an entity framework thing, or it could be MongoDB, and it doesn't matter. In Python, we don't really have that. You have to kind of like use the API for the thing that you're doing, but a lot of stuff you can kind of do similarly afterwards. All right. So they basically have linked to objects in Python, but they don't have anything else, right? In other words, so if you want to talk to like a database, there's a cool way to do it. It's just not unified, if you will. So let's see what we can write over here. This one is probably pushing if I call it LINQ, but let's define a person class. And our person class is going to have some variables. Self.name equals, well, let's say name. I'll do it this way, so to show you the tools. So I'm going to say name, and they're going to have an age, and they're going to have some hobbies. All right, so I can come down here and hit Alt-Enter. All right, Alt-Enter, just like you know and love from ReSharper. Like that, okay? So then I want to create an array of people. And I'll say, here's a person. And this is going to be Ted. Ted is 27, and Ted is not ambitious. He likes sleeping. Okay, comma. And let's see, there's Jeff. He is 40. He likes biking and surfing. And then I guess I'll throw myself in here. What am I, 26? I like rock climbing and that kind of stuff, right? And let's throw one more in there. Say Zoe's in here. She's 30. She likes swimming. So now we have this data set. We might ask interesting questions about it, like show me all the bikers ordered by, their age descending. That would be a typical link to objects type thing you would do, yeah? So I could say this. I could say bikers equals. Now, the way that you do this in Python is use something called a list comprehension, which looks like this is defining and putting items into a list. And it looks like I'm going to do the same thing. But instead, I'm going to write kind of a query statement. Do you guys remember when you first learned LINQ, how it seemed really wrong that you said from something and then a bunch of stuff? Because you're used to saying select the thing you want and then the clause and finally from X or Y, right? Well, it turns out that was a really good choice that Microsoft made because it was really clear what you're doing. Here, this is more like SQL. You have to say the thing you're going to select first, but you don't really know what you're going to select from yet. So maybe I just want the names of the bikers. So let's start up by just getting the bikers. So I'll say I'm going to get B from, not from, I always say from, for B in people. And you don't say where, you say if. Sorry, hold on, this thing keeps restarting and coming back. It would say if B, I want to ask the question, if something is in the hobbies list. So you can say that like this. You can say if biking is in b.hobbies. Okay, and that converts to an operator, operating there. Yeah, and so now if I just print out bikers, and run this, and I actually run the right program. See, it's totally perfect, right? What do I have to do? What's wrong with this? Basically, it's the toString thing, right? So I could either say what I want to do is actually project out the name, and look how awesome that is that it knows this. I want to select out the name of these people. Right? So this is like a select new b.name curly curly in my LINQ statement and get this. But if I want to work with them further, like do some sorting and stuff, I probably would just like override the toString up here. Okay. So it's not quite as beautiful as LINQ, but it's pretty sweet. The other thing that makes it not as awesome as LINQ is if there's a million people, this executes all million iterations, it turns into a list, and then it returns from that. LINQ is cool because it has lazy evaluation, right? It's not until you try to loop over it or call count or something does it actually touch the data source, and it only does it in kind of a lazy way. So Python has that as well, and it's kind of tricky to use it. So you change these from square to round braces. Now it has that sort of lazy evaluation. The reason is originally the LINQ, the list comprehensions were added to the language, and they're like, wait a minute, couldn't we do this better without like loading up a million records first? So this is called a generator expression. If I print this out, it doesn't look so awesome anymore. So I could either for loop over it, or I'll just like list it effectively, put it back. Okay. All right, so let's keep going here on this one. 2 PowerPoints, that's a problem. All right, so we could write this. We can also do the same thing over here in Python. I don't try to sell you guys that this is as good, but it's not horrible. Everything's kind of out of order. So the from part goes here, the where part goes there, the select part goes there, and the order part goes, there's not an arrow, but it goes to the very bottom, right? But it's okay. It's better than not having it. All right, now, one of the things that's amazing is NuGet. The ability to go to NuGet and just say, I would like a Facebook API, go. I want something that does secure hash folding for password management, go. Some awesome security guy's written that, not me, don't have to worry about it. If I want to use MongoDB, I can come over here and say, install the Mongo C# driver, and bam, now I have it, magic, and it'll keep updated. Python, we have that too, right? It's called this thing called pip. So instead of say install package manager, we just say pip install that, same type of thing. And we have NuGet, which is the repository to which we can run these commands, right? So having NuGet is amazing. And you're like, oh my God, there are 33,000 packages here. And really, that is amazing, you guys. It's a beautiful time to be a developer, right? Because that didn't used to exist. Turns out that Python has it too, and notice it has 56,000 packages. 56,000. Now, granted, I believe the dpdt, the derivative of the rate at which packages are added, is higher on NuGet than it is on what's called PyPy, Python Package Index. But because Python's been running this package index stuff much longer. But still, if NuGet is awesome, having twice as many NuGet things is even more awesome, okay? And the fact that it exists is really powerful. Okay. Whoops, go back. So how many of you guys know what this means? This is like one of the great unknown features of C#. But it's really amazing. So what it does is this creates a coroutine. And let's just look at how this works. Let's not necessarily study the C# too much. I'll just show you what the Python equivalent looks like, and then we can come back and talk about the C#, because this one I can execute. So here, yields. Okay, got to use something other than the keyword. So let's go over here, and what did we have? We had a thing that would generate the Fibonacci numbers, right? 1, 1. Add those two together to get 2, add the previous 2 to get 3, 3 to 5, 5 to 8, and on it goes. So let's say get Fibonacci numbers, and let's just write it without yield return for a minute. And hold on, let's just go down here and do our main. We'll just call it, I guess. Right, not really formal. So let's write it like this. Let's write it the non-yield return way. So what we would do is we'd say fibs equals an empty set. And we would say current equals 0. Sorry, guys. And we would say next equals 1. Now, there's a cool little technique we can use in Python to make this a simpler implementation. What we can do is we can say, we're going to take a limit here first, or we can just hard code the limit here. Let's take it past it here, limit. So we'll say while next is less than limit, we're going to do something. So we're going to see that the next value is equal to current plus next, and the current value, let me see. The current value is the old next. So I'll say this. I think this is right. Current equals current plus next, next. So something funky is going on there. This actually creates a tuple. When you say comma, it doesn't matter if it has parentheses. Creates a tuple, returns it, or assigns it, and this can actually decompose the tuple. So like Swift, you can use this to return multiple values from a method without out, or ref, or things like that. And so we're going to say this, and then we'll say fibs.append next. We'll just see how this works. Maybe current. Yeah, the order I read it, we should do current. So we'll say return fibs, and we'll see if we get this right. All right, which one are we running? Yes, okay. We run it. It wants some parameters. So let's say I want the first, the ones that are smaller than 100. So now if I run it, yay, my year in computer science didn't fail me. So all the Fibonacci numbers come back, And it seems like it's working great, yeah? Come on, back. So we come over here, and what is this about? Oh, yeah, there's a keyword called next that's actually built into the language. So let me just do this so you don't see warnings, right? So that was okay, but let's look at it a little more carefully. Let's do it like this. Let's make this go slow. We'll say date time dot sleep. I just want this time dot separate module. Yeah. Where's my sleep? I think I imported the wrong one. Hold on, sorry. Basically, I want threading dot sleep. That one. Let's say each one of these we're generating takes a second. And then I'll put a little output here. I'll say print generating next item. And I'll do this. I'll say print calling fibs. And then let's print done calling fibs. And let's actually do a for loop down here. We'll say for n in f print f. I'll say printing item. Okay? So what's going to happen? I'm going to call this, say calling fibs, I'll call this, it'll generating, then it'll be done, and then it'll print this out, right? That's standard procedural code, no magic here. And that 5 represents a decimal number, which is seconds. So it won't be super fast. Ooh, yes, thank you. It's about to crash. Wait 5 seconds. Oh, no, it's returning the sum of a function address or something. That's bad. Thank you. So you can see calling fibs, generating next item, generating next item, generating next item. Now, imagine I'm trying to do some processing where each little step is expensive to compute, like data science or pulling it off of a web service. And this, maybe I said the limit is 100. Maybe if I don't know the limit, I got to put that as super huge. And it's going to do all that work. And then maybe I read through, oh, actually, it was the third one I needed. Thanks anyway. All right, so both the C# and Python, they added this keyword. I'm kind of thinking 1 is a better number here, by the way. Both the Python and C#, they added this keyword. I think Python had it first. Python, they call it yield. In C#, they call it yield return. And either way, it will generate what's called a coroutine. You can see it prints out all the items. It generates a coroutine. And it doesn't do what this does. It does like what link does, where it sort of lazily evaluates it. So instead of doing this, let's do something totally awesome. Let's say true. I want all the items. I want all the Fibonacci numbers. And unlike a lot of the compiled languages, there's an unbounded limit to the size. Basically, your memory is the size of the integers you can do. So this would generate them until we ran out of memory of the 16 gigs I have or whatever. But this right now, if I leave it this way, will run out of memory and never return, right? It's just going to go around until that fibs thing crashes and boom, it's done. So let me do this. I'll say this. And instead of returning this bit, what we're going to do at each time we find one, we're going to say yield. What did I have before? Current. Yield current. So you're just going to go, here's an item in the set. Here's an item in the set. Here's an item in the set. Okay? And then we don't need to pass this. Remember, I'm getting all the Fibonacci numbers. Let's just say, you know what? If f is greater than 200, break without semicolon. So first of all, is this ever going to return from this function? Yes, it turns out it will, but let's see what happens here. All right. Oh, what did I do there? 923. Oh, sorry, n. So here you can see, generating, getting one. Oh, I'm also printing the wrong thing, sorry. This is a pervasive problem. And okay. So you can see calling fibs, generate next item, printing item, generate item, printing item, generate item, printing item, generate item, printing item. That's the infinite series that I am printing out there. Yeah? That's awesome, right? We just generated an infinite series. And it was actually less typing, not more, than the one that was bounded with the list and all that kind of stuff. So you can combine this kind of coolness with, which one? With these, and you can chain them together to create like a pipeline of transformations, kind of a data pipeline that's super efficient. You can do that in C# as well. This would be a link statement, and then yield return. But the fact that Python also has this. So like this is a really cool way to write this. It turns out it's not too bad to write it in Python either. Okay? You just don't say yield return, you just say yield. And you use the fact that you can project these tuples to like make it a little more concise. Okay. ASP.NET. How many guys are web developers, or at least part-time? Yeah, good bunch of you. MVC? Yes, of course. Those of you who aren't, you may be wishing you were. So this is really a fantastic web framework, right? It's both web forms of in its day and MVC today. These are really, really fantastic frameworks. Turns out we have some over here that are pretty excellent as well. All right. So there's a couple of choices here. Django is kind of like web forms. Flask and Pyramid are like MVC. Okay. But they've got a template language. You pass the model down to the templating engine, just like Razor. It's very awesome. Also, built on top of Flask, there's this thing called Eve, which is like Entity Framework, or not Entity Framework, it's like Web API. Okay. So very nice. Another thing that's awesome is the ability to go to your database and say, take these data shapes and map them to classes and let me do queries against them by interacting with the classes. So I could say from, P in person, where p.name or p.age is greater than 10, and that'll translate to select star from person, where, right? Like that kind of stuff. Turns out in Python we have basically the exact same thing. It's called SQL Alchemy. All right, it's been around since 2008, so I guess right around the same time frame. All right, so these are both semi-complex topics, so I wanted to go through an example of a site I wrote last weekend. So I'm starting a podcast called Talk Python to Me. You guys can check it out. But I want to show you a few things about it, just to look at the Entity Framework and web bits. So let's close this and go open that. So let me just first run it and show you something pretty amazing. So if I run this, do you guys know how quickly ASP.NET will respond if you make a request, sort of with no network latency, no processing whatsoever, those kinds of things? I think it's around 10 milliseconds or so. And that's kind of slow, actually, to be honest. That's why they're trying to redo the ASP.NET stack with what they call Project vNext and the Project K stuff and all those kind of things that are kind of funky. Every web request you make in ASP.NET, because it gets session, request, response, all those different things that are in your HTTP context, make up 33K before you start touching anything or creating a byte yourself, just by the virtue of landing on either a web form method or MVC action. 33K of stuff has happened. So it turns out that this framework is faster. Now, let me go over here. Let's go to this one. Let me pull up the dev tools here. Pull up the network. Hit reload. Maybe I don't want to see all that. How about we just see the main page? If I go over here. Four milliseconds versus 10 or 12. And this is not even a compiled language, you guys. That's awesome, right? I mean, you might think, okay, I'm willing to do this. Michael convinced me to try Python. I'm willing to have this slow site because of it. 4 milliseconds. That's pretty amazing. And there's some really cool tools over here as well. I'll show you the programming bits. But when you're running it locally, it goes into this debug mode. Okay, so let me click around a little bit. We can go check out the episodes. All right, that episode is awesome. I could become a friend of the show. Then I can click this little thing, and it goes into this debug mode. Let me make the fonts bigger. And it says, okay, apparently I missed a theme somewhere. I reorganized it. But here, look at this request here. I can click around. And it shows me all the request variables from like the route matching, right? I can see, if I come over here and click on this one, let's go and like do one more request. Over here, go to this one. You can see how many milliseconds the CPU server side took, about 1. What kind of Razor equivalent table thing did it find? I found that template there, that PT template. You could do logging and see what logging came out. This SQL Alchemy is like, show me what happened with regards to Entity Framework talking to the database as part of this page request. All sorts of stuff. If there was an error, here's the errors. Isn't that cool that you just get this as like a thing that comes out of the box? Okay, so let's go over here and let's look at a few pieces. How does this work? Well, let's put this away. So here is the friends of the show. Actually, let me show you one that's more interesting. Let's go to home controller. So here's the home controller. The home controller does a couple of things. It shows the home page, which has a view model, which is being passed to it. Now, technically, all the stuff that gets passed down has to be passed as a dictionary so the underlying templating engine can grab it correctly. So you don't call return view of model, you just return the dictionary like this. And you put the renderer up here. And if you don't have anything, like the about page is just static HTML, you just say this. And let's see, the episodes one is interesting. There's a little bit more stuff going on here. So there's an RSS feed of all the podcasts, which right now there's just one. I'm recording one next week. I just started this. Like I said, last weekend on Saturday, I did this. So here we're going to return all of the items that show up in the RSS feed. And because I said that this is a type RSS.xml, I can go here, go to RSS, and it comes out like that. Right? So this looks, I don't know if you guys are familiar with MVC, but this looks just like MVC. Right? It's a little more packed together because you don't have the curly braces separated, but derived from controller, you do this thing, off you go. And let's see, what else is over here? If we go to the project, well, that'll work, I guess. Didn't really mean it. Just went that. So we've got our controllers, and this I just put in there. Controllers, you got your data model. That's SQL Alchemy. We'll look at that in a second. In MVC, you can have a local DB or like a local MDF from SQL Express. We have the same thing, but with SQLite. Okay. We've got integration with MailChimp. I don't know if you guys are familiar with MailChimp, but this is like a subscription newsletter type of management thing, and then you can send out newsletters. So like if you became a friend of the show, your email would go in there. And in .NET, there's a cool NuGet package you can get that allows you to just call .NET APIs. In Python, same thing. There's a cool, pip install MailChimp, write these 2 lines of code, and you're done. All right? So very, very similar. Let's look at some of the templates. Like here's the RSS template. This is actually XML. It could be anything. But down here you can see shows for each episode when is the last episode date, and then it goes through. And in Razor you would write for each var en episodes, and then you would put a div. You would say like a div outside, something like, or an item outside rather. Sorry. And here you just use this little repeat syntax, and that it's more like Angular JS style. Okay, but instead of saying you say $ curly brace, and granted that is not as cool, because Razor is awesome, but it's not much different in practice. Okay, down here if you look at the, let's see, the episodes page, which is not that one, this one, you can see we have a table which has the head piece, and then that just lists all the available episodes. And it just goes to the view model, gets all of its episodes, and for each episode, it gets the guest name and the ID and things like that. Okay? Pretty cool? All right, let's go back here. All right. Let me check the time, sorry. Leave a little bit of time for Q&A. So the stuff that we've been running the whole time has been interpreted. And you might say, well, interpreted equals slow. Oh, actually, sorry, let me show you one more thing. I realized I wanted to show you two things with the website. The other one is the data access. So over here, we've got episodes. We have this little repository thing. Let's say that. We'll start here. And in here, it's got this initialization bit that doesn't really matter. It just finds the files and so on. It doesn't work with. And we might want to get all of the episodes from the database. So I have a class called episode, just like you would in any framework. And it has an ID, a title, an MP3 link, a recorded date. And these are string, date. They can either be nullable or not nullable. They can have default values or not have default values, things like that. This is not exactly like what you do in Entity Framework Code First, but it's very, very similar, right? In Entity Framework Code First, you would say just int duration or string duration or whatever it goes there, right? And it would just figure out. But so you got to say that this is a SQL alchemy column. But once you start using it, use it the same way. You could just say like self.description, right? So once you have one of these that derives from the right base class, I can come over here and I can say I want to go and create a query on episode where is published is true, order by, published date, descending. Or if I want to get a particular one, I can come there and say, give me the episode where the ID equals the show ID that was passed, and give me single, basically. Right? Cool, yeah? It's the thing that's not as cool is this is a totally different API than the object list comprehension stuff, the generator list comprehension. But still, not bad at all. All right, so everything that we've been doing so far has been interpreted. Now, that sounds slow, but you have to take it with a bit of a grain of salt, because a lot of the people that make these libraries, and that's what made me think of SQL Alchemy, there'll be parts where there's a performance critical section. And the people that write those libraries, they can decide, this little section I'm going to write in C, and then just plug that into my Python library. So the part where there's some sort of hotspots in the data access layer of SQL Alchemy that would be slow if it were in pure Python, so that part's written in C. So in fact, that's probably faster than JIT compilation. So there's parts that are slower because they're interpreted, but then there's parts that are actually written in C. Like, we don't have to worry about it, but the guy who wrote the library, they decided to do that. Like, there's a whole scientific visualization library, and a lot of that's written in C down at the low level. Right? So it's not really clear to compare like interpolation versus JIT compilation, because it depends on what it is you're trying to do. But generally, compiled stuff would be faster, right? It would be better. Well, in Python, we don't have that in the built-in one. But there's this thing called PyPy. And the reason it's called PyPy is this is a Python runtime implementation written in Python, which does what .NET does: JIT compilation, garbage collection, all that kind of stuff. So there's a JIT compiled version of the runtime if you want to use it. It does slightly less stuff. For example, it hates the fact that SQL Alchemy is written in C in a section, and it won't work with that part. Right? It's got to be a pure Python libraries that you work with. And there are pure Python versions of SQL Alchemy and so on. But so it's a subset of what it can do, but it's pretty awesome. There's also, very relevant to you guys, IronPython, which is, let me take my Python code and run it on the .NET framework with JIT compilation and memory, garbage collection and all that kind of stuff. That's pretty cool. There's another thing that you may like less, but some people love it, called Jython, which is the IronPython equivalent for Java. Okay? And then finally, there's this something called Python, which just came out like 6 months ago. It's not quite finished. It's just like PyPy, but it's notable because it's from Dropbox, which is in turn notable because that's where this guy named Guido van Rossum works. And Guido van Rossum is the guy who created Python. He's like the Anders Heilsberg of Python, if you will. And he and a few of the developers there are working on like basically a .NET style runtime for Python itself. Okay, so that's pretty awesome. Dropbox, by the way, runs a very large portion of its code on Python, server side and client side. So that's pretty interesting. All right. Maybe you want some kind of GUI designer. You want to create a UI app. Right? So far, we've created web apps. We've created scripting apps. So in C#, we have WPF, and you may or may not love it, but it does a lot of good stuff. I loved Windows Forms. I'm not sure I'm fully embracing WPF even yet, but I do plenty of it. So we could do this. In Python, if you want a fully cross-platform thing, there's this thing called Qt. PyQt is a library that lets you work with Qt from Python. And if you want to look at, one of the problems with these cross-platform systems is they usually look like they're cross-platform things. Like remember how Java apps used to look like, oh, that's not a real app. No, that dialog is not an open file dialog, PyQt looks much, much, much better. So here's an example of an app that's written in Qt. Oh, it's not running. Okay, great. So let's see. Can I edit just to show you some UIs? So that looks like a legitimate Mac app, right? But actually, it's written in, this happens to be written in C++, but it would look the same as if it was written in PyQt. It looks like a Windows app on Windows, and it also runs on Linux and looks like a Linux app on Linux. Okay, so I'll probably show you better if I just go to the website. RoboMongo. And they have a little animated roller thing here that shows you what it looks like in the different languages. All right, so that looks like a legitimate app. And so you can build Python UIs with something called PyQt or PySide. There's kind of a long history why there's two versions. And build these kinds of apps using this Qt framework. And that's pretty cool. Or you might decide that you really, really want native apps. Okay? So if you really wanted a native app, you would use WPF there. Well, over in Python, there's this Qt thing, like I said. But you can also use IronPython to create a Windows app. Or you can use something called PyObjC. It rolls off the tongue, doesn't it? But it's the equivalent of that. And it creates this one for OS X, and it creates bindings against the Cocoa APIs. So it literally uses, the stuff that goes on the screen is the native UI. But the runtime implementation is done in Python. All right, that's pretty cool. Let me show you a little bit about this. Yeah, we have just a minute or two. So let's go back over here, and I'll show you one more thing that we can do that's pretty cool. So new project, Python. Let's go IronPython WPF application. You guys know WPF? Familiar? Obviously know of it, but yeah, you seem to have stayed away from it for the most part. Some of you guys are doing it. It's good. All right, so here is our, let's swap these things. So you can see down here at the bottom, I've got my WPF thing, and I can do some little designery tricks. So I can create like a column here, and I can put some rows there. And I come over here and I can say, you know what? This row, these are all just like standard size. Let's say auto there. For the columns, let's say the first one is going to be however big it has to be, and then these are going to be star, right? So there's our grid, and then let's go into this grid for a minute, and let's say I would like to put a text block of that style in there, and it's going to be in grid.row. Why is that not giving me IntelliSense? 0 grid.column here. It's going to be 0, and this is going to be name, and we'll put a text box like this. There we go. And this will be in the second column, and so on. And let me just copy that. We'll put a name And we'll put age or something like that. Age. This will be in row 1. Whoops. Sorry. And then let's do one more. We'll have a button. And we'll say grid.row equals 2. This is not working so well, 2. And grid.column 1 here. We'll say, let's leave it like, oops. Go back to this view, and let's just do, it needs text. Let's give it the content. XAML is content equals click me. Now this is going to look not super great, but we can run it and see what we get. I don't think it's actually loving this, is it? Button, button, button. Oh, because of that right there. Okay, try this. Now you can see that looks like most WPF apps that you put no styling on. But I've got this bit over here where I can type, right? And I can click it. So let's do this. Let's go over here, go to the button, double click it, and just pause for a minute what this is over here. You guys can read that code by now. From system.windows, import app window, dev class windows, under init. It's familiar, right? Here's our button handler. If name, this, haven't really talked about that, but that just basically runs the main. So suppose we had a class up here. I'll just put it in the same file just so, because we're running out of time. Class person, def, under init. Self, I'm not sure why this is not auto-completing. Just do it like this. We'll say self.name equals Jeff, self.age equals 27. Oh, I did, didn't I? Thank you very much. Okay. Yeah, there's never enough underscores. So down here, if I wanted to data bind to this in C#, how would you do it? What would you write here in this constructor? Let me write the XAML first, and then you can tell me. That'll give you a hint. So over here, I'm going to need to write something like this. In this text box, I want to say text equals curly binding name. And down here in this one, I want to say text equals curly age, binding age. Like that. Anyone know? Set the data context. So I wouldn't say this, I would say self dot, and then data context equals, and I'll just allocate a person. And I'll run it. Why did that not run? Oops. Stop doing that. Maybe this needs to be below down here. It doesn't seem happy, you guys. I'm sorry. Oh, in the XAML? Oh, yeah. Thank you. That was an awesome error message. I'm glad I got it. Look at that. Thank you. Isn't that cool? Now, there's a problem. Final problem. Then I'll take questions. If we go down here to this, there's no bin folder here. There's no compiled app here. So you would just give your PYs and XAMLs away, or you might go, yeah, no, we're not doing that. There's a thing that you can get called CX freeze. And CX freeze will take Python scripts and generate EXEs from them that have no dependency on Python whatsoever, right? Because right now, if I give you that, you have to have the right version of Python installed and any other packages, like NuGet packages I'm using, also installed. But if I use this, you get an EXE that will run even without Python installed at all, okay? So that's pretty sweet. And then you can do the equivalent. There's a Py2 app for OS 10 apps as well to build a .app file. All right, so let me swip over here. All right, so this is pretty cool. And so you can do basically the same thing I just did for WPF. You can do that on OS 10 as well. All right, so that's Python. The main takeaway is there's all this stuff that is amazing about .NET, but it's generally available in Python as well. All right, so I think that's great. All right, so parting thoughts. If you guys want any training on Python, I've written a bunch of our classes at Developmentor, and would love to come talk about them. Questions? Yes?
What's Python's closest equivalent to the task parallel library .NET?
How does it have something like task parallel library? Yes, it has something like async and await, actually, which kind of blew my mind. That just came out like a little while ago. Maybe I'll write it in lowercase. Async IO Python. So there's this async IO sort of stuff where you can do, basically in .NET, you can kick off like a web request or a database query or something that's going to wait on an external piece. And then you can just say await that, and it'll sort of reuse your thread, or at least let other stuff in your app keep running, depending on what type of stuff you're doing, automatically. This async IO thing that came out in Python 3.4, which is the very, very newest version, is that. Now, the one thing it's not good for is computational parallelism. Basically, Python sucks for computational parallelism. If you're trying to do, oh, I want to compute this algorithm, I'm going to kick off 10 threads to just pin the CPU, not so much. Use .NET. Or use, if you also want the task parallel library, use IronPython. That's another one. You literally get the task parallel library.
Multiprocessing does a good job, though.
Yeah.
Pretty straightforward concurrence, and you can get all your CPUs.
Exactly. Yeah, you can use the multiprocessing module and do that, but it's not as simple, really, as the task library. Yeah? Other questions? Yeah?
What's your sense of how alive Jython and IronPython are? Jython seems dead, but I don't...
Jython definitely seems dead. However, I can tell you I taught a Python class at, let's say, one of the major video streaming companies, and they were all about the Jython, and that's all they would use. They wouldn't even use CPython. I believe Jython did have a release recently to catch up to 2.7 to Python, because it used to be until like 6 months ago, Jython wouldn't even support not the new version of Python, but not even the newer old Python. It was only like Python 2.5, which is super old. And I think Jython supports 2.7 now, which is not amazing. Yeah, big news. Jython 2.7 released in August. Yeah, so it's not totally dead, but it's not super vibrant, you know. I think the future where some of these things are, like Jython and stuff will go to like Python and PyPy, actually. By the way, I didn't tell you, but PyPy for some very non-trivial stuff is like 5 times faster than regular Python. So that's worth considering. All right, other questions? Yeah? Oh, packaging and versioning. There's some super nice stuff about packaging and versioning. Let me show you here. So when you go and install these other packages, they're packaged up into what's called a wheel, which is basically a zip file with some structure. And you can put versions in there, and you use PyPy just like you do NuGet to upgrade the versions that you have and that kind of stuff. But this web app, this framework here, packages up your web app as one of these packages, right? And so you can define these setup pieces and say, okay, my package here, it has a certain version. Right now it's at 0. I probably should upgrade that. It depends on all of these other libraries, all the pyramid stuff, the Waitress web server, SQL Alchemy, MailChimp. I talked to you guys about those. Here's like the name and stuff. And then I can come over here and tools, run setup task. I could run the setup and I could say, create me a bdist, egg, or whatever, and it would actually create the installable that I could give away and upload to PyPy, and then other people would have it. And then once they install it, they could say, you know, upgrade, check for latest version, And it would upgrade as well as like cascade those updates across these possibly, depending how you run it. That's not exactly the use of this web app, but the way they built it is it's built as one of these packages. So I can show you that at least, yeah? Other questions? All right, so yes?
So you said you're selling this session as using Python as a second language for .NET.
Yeah.
So when would you choose Python over .NET or vice versa?
This is a super good question. So when would you choose Python over .NET? Well, if you need cross-platform, here's a really nice, easy way to get cross-platform. Sometimes you want to run something on Linux. Like if you want to go into the cloud and create a Linux machine, they're typically half price to the Windows machines. So that might be a good reason to do that. I'm selling the session to you guys as it's a great second language, and I think it is. But I also want to communicate to you in the slides, like almost every single thing I showed you I thought was better in code in Python than it was in .NET, which is not a super big knock on .NET, but it's at least as nice of a language, in my personal opinion, right? You guys can disagree because you're like, white space, no, whatever, right? But so I just do apps in both. And the other consideration I have for choosing one language over the other is, am I working with somebody that either loves or hates one or two of the languages, right? If I'm working with a guy and he's like, I so love WPF and C#, fine, let's do it in .NET. If I'm working with somebody who's like, I will not turn on Windows, like, okay, well, let's not use .NET for this website, you know, that kind of thing. Yeah?
Just to add to that, I'd say that if you're doing scientific computing and you need to do advanced visualization, Python is probably
Yeah, it's unbelievable, actually. It's unbelievable. There's a thing called IPython that is just magic for this kind of stuff. There's an underlying library that really work together called SciPy and associated one. So if I go over to SciPy, yeah, thanks for that. So there's this thing called NumPy, which is like super advanced matrix math. SciPy for like science computing, Matplotlib, and then IPython is grouped in there. Symbolic math, like please solve this series of linear equations, and then pandas is like amazing data science stuff. Taken together, those are like killer, yeah. And you really don't have that in .NET at all. I mean, there's very little like big data visualization stuff in the language. You can say, well, go get Power BI. Well, okay, that's not a programming language. That's like an Excel plugin or something, you know. All right. Let me show you one more thing, just super, super quick, and you go. If you guys need to host this stuff, you can host it on Azure, you can host it on Google Web App, you can go to EC2, create a VM. But right down the street, there's this place called Python Anywhere. They're here in London. And you can come up to this place and create a free website that'll do up to 300,000 page views a month for free. It gives you a free database as well. But after that, you got to pay. And to work with it, you can come up and just create a shell in your browser. And it even remembers where you were last time. So here's my remote shell into the web server for that Python, Talk Python to Me podcast. And just use Git to put this stuff up there. All right, and so you can come in here and you can pip install. Let me do it like this. Pip list. And you can come up here and install whatever you want into the server. They basically give you access to go install all these things that you want to work with. And then you just say, run that, please. Right, so you don't, it's kind of like a weird take on platform as a service versus infrastructure as a service. It's like a hybrid. And that's free, and they also have paid versions. If you want your own domain, for example, you got to pay them $5 a month. Anyway, so very nice stuff. Hopefully you guys feel like there's some more interesting stuff out to learn. There's never an end of all the things you can learn, right? It's only increasing, but here's one more for you. Thanks for coming.